Good afternoon students. In today's class we are going to discuss organic chemistry, alkanes, alkenes and alkanes, the important preparation methods and properties. So first and foremost thing, if we are taking a laboratory preparation of methane. So how do you write this method? First point, write the reactants. So what are the reactants here? That is sodium ethanoate and soda lime. Sodium ethanoate and soda lime. And you need to understand an important concept that soda lime is helping in decarboxylation reactions, and hence it is called as decarboxylating agent. So it helps in decarboxylation reaction. So what is meant by decarboxylation reaction? Removal of carbon dioxide in the form of sodium carbonate. Hope you have understood this, and in the reaction we can see that clearly. Next, sodium ethanoate, CH3COONA, right? Then soda lime is NaOH in the presence of calcium oxide. So the reaction is heating. What is the role of calcium oxide in this? So we know that NaOH, if you leave it, it will absorb moisture from the atmosphere and becomes liquid. Deliquescent nature you would have seen. So to avoid that particular thing and keep NaOH in the solid form, we are using calcium oxide, which helps in the drying of NaOH. Fine. Now the reaction is decarboxylation. So what we will do, we will remove Na2CO3 like this. So on removal of Na2CO3, what is left out? Here you observe CH3 and on the other side H. So therefore methane is prepared in this process. Hope you have understood this. Now in this we also have to see the collection of methane gas. So in the diagram what they have mentioned, always methane gas is collected by downward displacement of water. So downward displacement of water, right? Why it is collected by downward displacement of water? Because it is slightly soluble in water and also it is lighter than air. Hope you have understood this. Suppose you want to make ethane. So once again you can write the reactants. So what are the reactants? We have sodium propionate, okay, and soda lime. The same reaction, decarboxylation. So prop means 3 carbons. So we have COONA like this. So this is nothing but ester, CH3, here CH2. So this is called as sodium propionate. Now writing the soda lime, again NaOH in the presence of calcium oxide. On heating, this will remove Na2CO3 like this. So nothing but minus carbon dioxide, decarboxylation reaction. So due to this we get sodium carbonate plus, what is the product obtained here? You can observe this is C2H5 and here you are having one hydrogen, hence you can write it as C2H6. So in this way we can prepare ethane. Next, what are the other methods of preparation of methane and ethane? So first and foremost thing is, you can take iodomethane as the starting material. So what is iodomethane? CH3I. So to this we add a nascent hydrogen. So how nascent hydrogen is added? If you take zinc powder in the presence of dilute HCl, then it will liberate nascent hydrogen. So pure form of or atomic form of hydrogen is called as nascent hydrogen. Here understand that you are adding one hydrogen here and one H here. So you are getting CH4 plus HI. So this reaction is nothing but substitution reaction. Next, one more method is take aluminum carbide. Al4C3 is known as aluminum carbide. To this, on addition of 12 moles of water, you get 4 aluminum hydroxide. Along with that, you get 3 moles of methane gas. So this is your second method. Next, important reaction is how do you prepare ethane, only ethane, methane cannot be prepared from alkyl halides. From alkyl halides. So remember Rx is the representation. What is R group? R group is alkyl, X is halogen. So you know very well how do you get alkyl groups? Alkyl groups can be obtained by taking alkane minus 1 hydrogen. So this we have seen in the previous classes. So you take CH3I, this is R and this is X. So methyl iodide you have taken, plus sodium, and again you can add methyl iodide. In the presence of a dry ether solvent, why you are taking dry ether here? Because sodium is highly reactive with moisture or water and liberates hydrogen, which is flammable. So for that reason, to avoid the reaction, you are using dry ether. Now here 2NaI, sodium iodide is removed, then what is left out? CH3 and CH3. So nothing but ethane. So this is known as Wood's reaction. Wood's reaction. Now important thing is, in give reason question you will get this, why methane cannot be prepared from this method. So Wood's reaction, methane cannot be prepared, and as it is odd number of carbons, you cannot prepare this. See, always remember the first compound which we take is single carbon is CH3X. So if you are adding another molecule of CH3X, definitely the first compound synthesized is ethane but not the methane. Next, what are the important chemical properties of alkanes? So we know very well that alkanes are saturated compounds. What do you mean by saturated compounds? Means the tetravalency is satisfied by 4 atoms. Those compounds are called as saturated compounds. And remember that the important reaction shown by saturated hydrocarbons is substitution reaction. Why you can do only substitution? Because already carbon has valency of 4 and you are having hydrogens, 4 hydrogens. To introduce another atom, what you need to do is either remove any of the hydrogen and replace this. That reaction is known as substitution reaction. Suppose you are taking unsaturated carbons like alkene like this. So here if you take the first carbon, it is surrounded by 3 atoms. So it is known as unsaturated. Tetravalence is satisfied by only 3 atoms. So in this condition, what we can do is we can easily add atoms. So one hydrogen can be added here, another hydrogen can be added here. Similar is the case of alkynes. So this is also called as unsaturated because the carbon is surrounded by only 2 atoms. Instead of 4 atoms, it has only 2. So you can remove the bonds and add some other atoms. So always remember, addition reactions are shown by unsaturated compounds like alkenes and alkynes. Now let us start the chemical properties of methane and ethane. The very first one is known as combustion reaction. So combustion reaction, you can have 2 things. Number 1 is if you take enough oxygen, so we will observe complete combustion takes place, and if you take insufficient oxygen, you will have incomplete oxidation or combustion. Suppose you are taking methane plus oxygen on heating. Always remember the products of combustion are carbon gets converted into CO2 and hydrogen will get converted into H2O. So this is the product. So therefore carbon will give you CO2 and hydrogen will give you H2O. And to balance this, always you have to follow the order of carbon, hydrogen and oxygen. Now first see how many atoms of carbon? 1. So if you observe 1 mole or 1 is the coefficient, write 1 here on the carbon dioxide. Second one, hydrogen we have 4. So to balance this, write 2 coefficient here. Then finally count the oxygens. So oxygens are 2 plus 2 nothing but 4. So therefore here coefficient will be written as 2. So this is known as complete balanced equation. Second one, you want to take ethane as an example. C2H6, again combustion means burning oxygen, burning this compound in the presence of oxygen. On heating, what will happen? carbon gets converted into CO2 and hydrogen will get converted into H2O. Hope you are able to follow this. Next, again I told the balancing will be in the order of carbon, hydrogen and oxygen. So therefore what we will do, we will see carbon. So we have 2, so coefficient 2 is written here. Next, 6 hydrogens are there, so write 3 H2O. After this count the oxygens, 2 into 2 4 plus 3 into 1 1. So 3 into 1 3, so total is 7. If it is an odd number, immediately what we have to write is that odd number divided by 2. Then this will be balanced equation only, but to have a whole number ratio, what we should do, multiply the equation with 2. Hope you are able to understand. If it is odd number, you write the same number divided by 2. On multiplicating, you get 2C2H6 plus 7 by 2 into 2, 2 gets cancelled out and this is 7O2. On heating gives 2 into 2 4 CO2 plus 3 into 2 6 H2O is formed. So this is about the complete combustion of both methane and ethane. Next, second one is if you are taking insufficient oxygen, then you will get incomplete combustion. So let us see. So methane with 3O2 gives us carbon monoxide. So the product of incomplete combustion is carbon monoxide. Along with that, water is liberated. Same balancing order you follow CHO here. Second one is if you take C2H6 plus O2, you are going to get once again incomplete combustion product, that is carbon monoxide and water. So you want to know the balancing process. So 2 carbons, write 2 as the coefficient, then here mention 3. Now if you check out with the oxygens, 2 plus 3 gives 5. So once again follow the same order, because it is an odd number, write it as 5 by 2. Now to get the whole number, multiply the equation with 2. So therefore 2C2H6 plus 5 by 2 into 2 is 5 here. O2 gives us 4CO plus 6 water. So this will be your incomplete combustion reactions of methane and ethane. Next, second one, substitution reaction. Now if you are taking methane, understand that there are 4 hydrogens, therefore you are going to get 4 substitution products. CH4 you can write like this. Now important thing, you want to add chlorine, so Cl2 you add. Next, if you want to have better understanding, write Cl-Cl, and H nu is nothing but diffused sunlight. So what is meant by diffused sunlight means you can use a curtain or you can use an umbrella like this. So direct sunlight is not there, it will be considered to be diffuse sunlight with less intensity. Now what will happen, here you can remove this hydrogen and substitute with the chlorine. So therefore first hydrogen you removed, so we are going to get, this is methane converting into chloromethane. So we know the IUPAC nomenclature, so I have written the product chloromethane plus HCl is formed. So this is your first product. Now what we will do is, this chloromethane once again undergoes the substitution reaction such that second hydrogen is being removed and substituted with the chlorine under same condition. So what you get now, you are going to get here also substitution of chlorine. So this is called as dichloromethane. So you underline D, C and M, and you can also call it as a DCM. So dichloromethane. What is the next substitution here? The third product can be obtained by removing one more hydrogen. So that means Cl and Cl substitution takes place with one HCl like this. So H will go and bind with this. So you are going to get 3 chlorines like this. So what do you call this? This is called as trichloromethane. And what is the common name for this? CHCl3 is also known as the chloroform. So we can call it as a chloroform. Now one more product is formed. Why the last product you are going to get? Because you are still left with one H here. So the last hydrogen is substituted with the chlorine like this. This chlorine will substitute and this will be removed. So you are going to get on all the sides the chlorine. So this is called as tetrachloromethane. Tetrachloromethane, because 4 hydrogens replaced with 4 chlorine. And also common name is nothing but carbon tetrachloride. Carbon tetrachloride. Hope you have understood this. One more important thing is, if they are asking you to find out what are the substitution products of ethane, so understand there are 6 hydrogens, therefore definitely you are going to get 6 substitution products. So directly I will write this: C2H6 plus Cl2 gives us, first one H is replaced, so C2H5Cl. So what do you call this? This is called as chloroethane. Then one more Cl2. So if you are adding chlorine, what happens? One H is substituted and one Cl will come here. So you will be having C2H4Cl2. So this is called as dichloroethane. Hope you are able to understand this. Next, there are still 4 hydrogens, so you can remove the next hydrogen. So next hydrogen you can remove. So you get C2H3Cl3. One chlorine is added and one hydrogen is removed. This is called as trichloroethane. Then next, if you are adding Cl2, what will happen? Once again one H is substituted with the Cl and you are going to get C2H4Cl2. So C2H4Cl2. So this is called as, earlier one was it is H2Cl4. So this will become tetrachloroethane. Now there are only 2 hydrogens left, so you will again get 2 more products. What are those? Cl here and H will come out, so you get C2HCl5. This is known as pentachloroethane, because 5 chlorines you call it as pentachloro. Then the last one, the last hydrogen is replaced with the Cl and you are getting C2Cl6. This is called as hexachloroethane. Hope you have understood the substitution products of both methane as well as ethane. See, catalytic oxidation, slow combustion, they are not in the syllabus, so we need not discuss that. Next, let us move to alkenes. First one, preparation. How you are preparing alkenes here? Very important reactions we have, that is, first one is called as dehydration and second one is called dehydrohallucination. See, D means removal, so what you are removing? Hydration means water, so here it is removal of water. Here D is removal, hydrogen you are removing and halogen also removing, so we can remove R and X. R is not, HX. So here H means hydrogen, X means halide, so removal of hydrogen as well as halogen. So let us see what are the reagents here. Dehydration is always done in the presence of concentrated H2SO4, hence concentrated H2SO4 is also called as dehydrating agent. Very important thing, organic reactions can be studied in the form of reagents. Then dehydrohallucination is done by alcoholic KOH. Right, so see, alcohol with the KOH. Let us see the first reaction. So what are the reactants in the dehydration? So first one is ethanol and the reagent concentrated H2SO4, which will be removing water. So here I will write it as dehydration reaction. Now let us write the structure of ethanol. So ethanol is like this, OH. This is, here we have hydrogens. Understood? Now, in the presence of concentrated H2SO4, on heating, what will happen is, anyhow I will tell you OH will be removed from here, no doubt. This is called as alpha carbon. Why it is called as alpha carbon means the carbon which is connected with the functional group is always known as alpha, and the next carbon is called as beta carbon. So we have an important term called as beta elimination. What is meant by beta elimination? Elimination means removal. So what you are removing, one hydrogen is removed from beta carbon, So therefore if you remove this reaction is called as beta elimination. Hope you have understood this. Now what will be formed here? We are going to get CH2 double bond CH2, which is nothing but ethane, plus what are the other byproducts here? You are going to get water. Hope you have understood the dehydration reaction. Second one is dehydrohallucination, that is removal of hydrogen as well as halogen. And the agent, we know what is the agent here, alcoholic KOH. So what is the starting material? The starting material is chloroethane, okay, plus alcoholic KOH. Again expand the structure here, so this is Cl, and on the other side you are writing hydrogens, right? So very important thing, use alcoholic KOH. So what will happen, this is called as alpha carbon because functional group is connected to this, and this is known as beta carbon because it is adjacent to alpha. As usual, you know the reaction can be also called as beta elimination, that means hydrogen is removed from beta position. So after removing, what you are going to get, you are going to get CH2 double bond CH2, which is known as ethene. So you get your product. Now other byproduct according to the textbook, K plus and Cl minus will give you KCl, and OH minus and H plus will give you water. So you are also going to get KCl as well as H2O. So this is about the preparation of alkenes. Next, what are the chemical properties? Very important reaction. Always unsaturated will undergo addition reaction. So in this, if you are adding hydrogen, then that reaction is called as hydrogenation. And very important thing is, what is the catalyst used here? Nickel, platinum or palladium. If you use nickel, you need to heat this. If you are using platinum or palladium, room temperature is enough. So ethene, we have the compound, so therefore we will discuss addition of hydrogen to this H2. So at 200 degrees in presence of nickel catalyst, what will happen? One hydrogen is added here, another hydrogen is added here by the removal of double bond. So what is the product obtained? CH2 plus H gives CH3. On the other side also you are getting CH3. Hence the product obtained is ethane. So this is about hydrogenation, first addition reaction. Now second one, if you are adding X2, that means nothing but halogen, that reaction is known as halogenation. You can take example of chlorine or bromine. Now the structure of ethene, CH2 double bond CH2 plus Cl2. So what we can do is a removal of this double bond, addition of chlorine, one chlorine atom here, another atom here, will give you CH2 here, Cl, single bond, CH2 and Cl. So what you are going to get, this is first position, second position, it is 1,2 dash dichloroethane. Similarly, if you add Br2, you will get 1,2 dibromoethane. So same addition reaction. So this is the second one. As you are adding halogens, this reaction is also known as halogenation. Next, see, polymerization, oxidation are not there in the syllabus, but we can also have addition of water, H2O, third reaction. Removal is called dehydration, so addition is known as hydration. So what is meant by hydration? We are adding H2O. Again take CH2 double bond CH2 plus H2O can be written as HOH. In presence of acidic medium, you can understand this is H plus and OH minus. By the removal of double bond, add H to this and OH to the other side. So what you are going to get? CH3 dash CH2 dash OH. So nothing but the product obtained is ethanol. So hope you have understood this. Next, The third hydrocarbons, that is alkynes. So how we are going to study the preparation and properties? First one, laboratory preparation of ethane. So CH triple bond CH. What are the reactants here? That is calcium carbide and water. So calcium carbide and water. If you are writing the formula, CaC2 is calcium carbide and 2 moles water will give you. So you can also remember like this. Can we write it as H plus and OH minus? Yes, 2H plus and 2OH minus, you write. Then Ca is 2 plus. So what is removed here? OH minus and Ca2 plus will form CaOH twice. Plus what is other thing? C2 and H2. So C2 and H2 can be written like this, C triple bond C and other side H. So this is nothing but ethane. Right, hope you have understood this. One more important thing is, in this particular laboratory preparation, you are getting the impurities like phosphine PH3, H2S hydrogen sulfide, NH3 is ammonia and arsine AS2S3 arsine. So these are formed along with ethane. So what is the reason? Because calcium carbide will also combine with sulfur and you will get these products, right? Now what we do, how to purify this? To this add water. And one more important thing, what is the smell of PH3? It is rotten fish smell. So PH3 gas is rotten fish smell and H2S is a rotten egg smell. So for one more question you can remember this. So what we will do, on passing through water, what will happen? Except phosphine, all the other things are dissolved in water. So we can remove these impurities easily by addition of water. So phosphine is left out, it doesn't react with water. So how do you take this? By the addition of acidified copper sulfate. So in the presence of H plus acidified copper sulfate, what it will do, it will take the phosphine and you are going to get the products with the copper sulfate. So phosphine can be removed by the addition of acidified copper sulfate, or you can also add acidified K2Cr2O7. Hope you have understood this. First add water to remove H2S, ammonia and arsine. Then add copper sulfate acidified or acidified potassium dichromate such that you can remove phosphine. Now second method of preparation, what is that? From 1,2 dibromoethane. From 1,2 dibromoethane you can prepare ethane. So the structure is CH2Br and this is CH2Br. So first position, second position, 1,2 you have written. Then alcoholic KOH we have to add. So take it as 2 KOH. You can write like this also, no issues. So what will happen? K plus and Br will be removed like this. So you will get 2 KBr. Now one more important thing is, here this reaction alcoholic KOH is known as dehydrohallucination. So halogen is removed and hydrogen is removed, one from here and one from here. So you are going to get 2 moles of water. So what is left out finally? CH triple bond CH is left out, which is nothing but ethane. So hope you have understood this reaction. Next, what are the chemical properties? So chemical properties, first one, if you take oxidation of ethane, you know very well what is meant by oxidation. In the presence of oxygen, if you heat the hydrocarbon, carbon gets converted into CO2 and hydrogen will convert into H2O. This is exothermic reaction. Now take CH triple bond CH plus O2 in the presence of oxygen. You are heating this, so the product will be definitely carbon dioxide and water. An important order of balancing, I told it is CHO. So take carbons 2. So write 2 here. Then hydrogens are 2. So this is already done. Next, calculate the oxygen. 2 into 2 4 plus 1 is 5. because you are getting an odd number according to the method, add coefficient as 5 by 2. Now to get the whole number, the method is multiply the whole equation with the 2. So therefore you get 2 C2H2 plus 5 by 2 into 2 5O2 gives 2 into 2 4 CO2 plus 2H2O. So this is the balanced equation for the combustion of ethane. Second reaction, the characteristic reaction, nothing but addition reaction shown by the unsaturated compound like ethane. So first one, add hydrogen. So this is done in the presence of catalyst. So you also call it as catalytic hydrogenation. Catalytic hydrogenation. So once again, you know very well, catalysts are nickel, platinum or palladium. If you are taking nickel, you have to heat this. So take the ethane structure plus H2 in presence of nickel, heat this. So what will happen? Here one H is added and the second carbon one H is added. So therefore removal of the pi bond or triple bond, one bond you are removing, you get CH2 double bond CH2. So ethane, when you are undergoing addition reaction, will convert into ethene. So double bond is formed. Then if you are adding, imagine you are adding chlorine. So addition of chlorine is known as a chlorination reaction. Chlorination reaction, because it is halogen, you can also call it as halogenation reaction. So taking CH triple bond CH in Cl2, right? So what will happen? First and foremost thing is one Cl can be added here, another Cl can be added. So you are going to get chlorine, double bond C and one more chlorine. So first carbon, second carbon, so 2 chlorine. So can we write like this, 1,2 dash dichloroethene, right? Now there are unsaturated carbons here. So once again, if you add Cl2, you will get the final product. What is that? Add one Cl and another Cl here by the removal of double bond. So you are going to get a product like this, CH. Here you have Cl, Cl, single bond carbon, Cl and Cl and H. So this is called as tetrachloroethane. Tetrachloroethane. So this is about the chlorination. Similarly, similar to this, if you are taking bromination, so imagine in the place of chlorine, take bromine Br2, and this reaction will become bromination. So as simple as that, in the place of Cl you are taking Br, so bromine, one Br is added, another Br is added here. So what are you going to get? In this reaction you will get Br here. So as simple as that, similar to chlorine, we are doing the same reaction. So therefore it is 1,2 dibromoethene is formed. Next, one double bond is there. So therefore if you are adding Br2 to this, the pi bond is removed. So hence on all the hydrogen sides you have taken Br here. So this is the final product obtained, and this is known as tetrabromoethane. Hope you have understood both the chlorination as well as bromination. Next, the last reaction is addition of HCl. So you take ethane plus HCl. So what will happen? Here one H can be added and here Cl can be added. So you are going to get, by the removal of third bond, that is triple bond or pi bond, you get CH2 double bond CH and here Cl will come. So this is nothing but chloroethene. Next, you add one more molecule of HCl plus HCl. Now what you will get, this H will be added here, Cl is added by the removal of double bond. So the product obtained is CH3 dash CH, this is one Cl, this is second Cl. Now 1,1 dash dichloroethane. So this is your product. So hope you have understood this. So this is about the preparation and properties of the hydrocarbons, alkanes, alkenes and alkynes. So thank you so much.